All right, here we go. Extra example. So it's an extra example here. Let's take a look, see what we can come up with. In this case, again, both sides look fairly complex. So I don't know that I love them, but that's all right. We can see what we can come up with here. In this case, what I want to do is, I'd say change to sines and cosines. That might be a good strategy. But I notice that I have this the same as this. But I have a plus here with a 2. So what let's do is let's take one fraction, something like this, and break it into two fractions. Something like this. So break it into two. Same thing up here. We're going to say 2 over cosecant theta secant theta plus cosecant theta plus times secant theta over cosecant theta secant theta. Reason for doing this should be fairly obvious. What happens in this term? Crosses out. And I'm left with 2 over cosecant theta secant theta plus 1. Now, don't forget you got to give your reasons. There's our given. In this case, it is fractions. And in this case, it is simplify. And so now at this point, we're getting closer, sort of. It doesn't look much the same yet, but it should. In this case, there's no plus or minus sign, so I can take cosecant and replace cosecant with 1 over cosine. I'm sorry, 1 over sine. Now, but because cosecant is in the bottom, 1 over cosecant theta, that's going to equal sine theta in the top. That's a property. So I have sine theta. And secant theta turns into cosine theta plus 1 equals sine plus cosine squared. And that's done by reciprocal. Now, at this point, I can't do a lot more over here. And that's where that third technique comes into play. I can't cross anything over, but I can go over here and simplify. Well, if I have x plus 2, the quantity squared, that's the same thing as saying x plus 2 times x plus 2, and foiling. Same thing here. Sine theta plus cosine theta times sine theta plus cosine theta. If I foil it out, I get sine squared theta plus 2 cosine theta sine theta plus cosine squared theta. That's nothing more than FOIL. All right, well, at this point, I say, wait a minute, that matches this. If I could just get rid of a sine squared plus a cosine squared. What family of properties allows us to get rid of sine squared plus cosine squared? Obviously, Pythagorean theorem. Sine squared plus cosine squared equals 1. Sine squared theta plus cosine squared theta equals 1. So I have 1 plus 2 cosine theta sine theta by Pythagorean theorem, and that equals 2 sine theta cosine theta plus 1. Those two now match, and I have a solution. Okay, there's another example.